Gordon and unmute. All right, very good. Hello. Well, we got two people. It's all right. I'm recording this, so if you don't want to speak, don't speak. If you want to speak, speak. I'm gonna post this there to YouTube later. I'll probably do it in, I'll take a break every hour, so it'll be segmented. We'll do the first bit here from 2 to 3, and then we'll do this, and then I'll take a break, and I'll pause the video, and we'll take 10, and then we'll go and do the last hour from 3 to 4. And then for tomorrow's lecture, I'm just going to post a video, the same thing there of what we got, in a lot of ways, yes, the VR is, I enjoy teaching in the classroom much more, but I'm trying to figure out just the whole mechanism. I want to record my classes because, I would really appreciate you guys having the class available whenever you want. And if you have a free 2 hours of study at 11 o'clock on a Thursday night, well then, you know what I mean? I'd like to be available, at least in video form. So I'm working on it, and the school's working on it. So anyway, I hope you guys are doing well. All right. Just a little bit of blabber here before we get started on the kidney, which is so cool. So again, we're doing VR now. We're gonna do VR tomorrow, so there's no class there tomorrow morning. Okay, for Wednesday. There'll be a video. There should be about 4 videos there for this class. 1 hour, 1 hour, 1 hour, and 1 hour. That's how I'm thinking it'll go. Yes, the PowerPoint it's been updated yesterday or the day before. What else is there? Your assignment, I think that's due there this week. All right. Wednesday midnight, we'll do fine. Okay. Everything's on Blackboard. Punch in your answers. You can see your score right there. If there's any issues with that, just shoot me an email. Come and see me, and we'll square it all up. Yes, the kidney lab is posted, and the kidney lab is just like the heart. There's no, but you know what I mean. The heart was like yay big of a report. The kidney will be like that big. Not too bad. So the kidney lab is posted. So next week, so here we have today Tuesday, we have tomorrow Wednesday, both VR. Assignments due tomorrow by midnight. Next week, week 11. Okay, there is no Tuesday class. You're free. Okay, the kidney lab. Okay, that'll be on the Wednesday. And that'll be in the same room as before. I think it was M325. I'll send an announcement out just on the kidney lab there, probably Thursday or Friday there this week or something like that. There's no point in sending an announcement out 2 or 3 weeks early because you got to send them all again anyway. So, but we do have the kidney lab there next Wednesday. And honestly, it's about an hour max. Okay, because there's not much to it. All right. And the report will be the kind of the same style. I really enjoyed your heart labs. Honestly, for the most part, they were outstanding, and everything looked all right. I've got those to give you back. I'll give you those back there next week in the kidney lab. I'm not going to see you until next Wednesday. Oh, well, enjoy it. But other than that, we're starting to wind things down. Can you believe it? Week 10. Okay, there's basically only 3 more weeks of school. 11, 12, and 13 after this, because week 14's a write-off anyway. So you guys just keep on trucking. Keep on going. If there's any questions, let me know. Okay, give me lots of time. People are still getting COVID. People are still, I don't know, man. I haven't heard any monkeypox yet, but there's, who knows? We just kind of keep our head down and we just keep on moving. And I expect you guys to do that. Keep on it. All right. I think that's it for now. I'm sure I'll think of something there along the way. But if you guys are good, let's go. Now, it's been a while since I've used this one here. There we go. Perfect. So, let me know if you guys can't see anything or if I've hit the mute button by accident. I can't really see any comments, so honestly, rules apply, same as a classroom. Just shout out, man. You know what I mean? Don't raise your hand. Shout it out. Let me know what's going on if there's an issue.
Hi, Ian.
How are you?
I'm good, and you?
I am very good. What can I do for you?
The opportunity. Nothing. I'm just saying hi.
Oh, well, that's the nicest hi I've had today. Thank you so much. Thank you so much.
Welcome.
All right. Let's hit it, shall we? Urinary. And for anyone who's joining late or whatever, well, there's only the two. I guess there's really no point. But anyone who decides to join late, they don't worry. Everything is recorded. So let's go. Urinary system. I've been waiting for this one since about week 4. I love it. One of my favorites. Welcome to the kidneys. And these are it. All right. When we're talking about the urinary system, of course, you'll see there the kidneys. You'll notice there that one is higher than the other, and that is your left kidney is a little higher. See if I can zoom in here a little bit. You'll see there that there are my adrenal glands. Okay, they work in association with the kidney, but they're more so with the endocrine system. But we'll get there. We'll talk about them there today as well. So there are your kidneys. All right, and you'll notice there that you know, the kidney beans that we all enjoy eating, this is the same shape, and this is where they get their name from. And you'll see there that this little indentation of the kidney, there's a name for it called a hilum. All right, that's that little bend deviation in there. All right. You'll see there that we have the renal artery coming in. Okay. All right. There's your descending aorta. Okay, and here's your vena cava. All right. And you've got your renal artery coming in. And you'll see there arteries. What kind of pressure are we talking about? I think you guys are going to have nightmares of pressure and all this kind of stuff years from now because I've ingrained it in you. But arteries, man, massive pressure. Boom. And look at that. That artery is going straight into the kidney, and there's not much of a kidney for that artery to go into. So you can see that this blood is going to hit a wall, which is the whole point. We'll get there. And there's your renal vein there. Anyway, we're going to go through. Blood comes in, and it gets filtered. All right? And the blood comes out, choom, right to the heart. Okay? But any type of urine that's created, you'll see there, drops down. You'll see that there's 2 ureters, okay? And they travel all the way down here, okay? And then you have your bladder, okay, which has these transitional epithelial, okay? They have a bit of stretch to them, and when they get too stretched, all right, the message there is sent to the brain, hey, find a bathroom. And that's what it says to the brain. Yes, that's right. And there's your urethra. Okay, we'll talk about that there as well. Interesting little note there that maybe I like to put on a test. Actually, I'll save that one for a little bit later. All right, good enough. Everything's cool. There we go. I'm just trying to find a place to put that. Will that fit down there? Okay. Just to keep my face in there. There we go. Perfect. Functions of the kidney. We've got filtration, of course, right? Of these metabolic wastes there, we got to get them out. And we'll tell you about all these there. Collection and excretion. Okay? Getting everything organized. And big bananas here, regulation of RBC production. Absolutely. blood pressure, big banana. Calcium ion absorption. We don't throw that calcium away. It's good stuff. Blood volume composition and pH. Okay, lots going on here. And to do the kidney in 4 hours, I apologize, kidneys. I'll never be able to do you justice. But thank goodness most learning occurs outside the classroom, and you guys have your textbooks. Give it a read. Honestly, it's great reading, especially at 10 o'clock at night while you're lying in bed. Puts you out like you wouldn't believe. You'll see there that I've got movies all over the place in here, and since I'm going to be posting this on YouTube, how do they say this? If you post anyone else's material within your YouTube video, then you're not entitled to any of the money. Well, I'm not looking for the money, but I just don't want to get into trouble with any type of copyright infringement. Okay, but the movies are good there. Like this one here, gluconeogenesis. Okay, just the whole idea of producing and making glucose. Okay, pulling it off the shelf and throwing it into the blood during times of fasting. Okay, like that's a good one. Okay, when people aren't eating for whatever reason they are. Okay, anyone who just joined, don't worry, you didn't miss anything. We're only on slide number 3. I've been talking too much as usual, right? But I'm recording this, so everything's cool. I'll post this there to YouTube there later. Endocrine functions there, we've got renin. Okay, regulation of blood pressure and kidney function. Big banana. Erythropoietin, regulation of RBC production. Activation of vitamin D. There's lots going on here, and we'll hit all these. Again, the movies I will not be playing, but since you guys can watch this, you're watching this video recorded, okay, you can pause the video, hit this, go watch the movie, come back in. Okay, that's one of the advantages of that. I'm not wasting class time. You're watching these movies in your own time. Watch them, don't watch them, whatever. But that's one of the things I like about VR. Moving on here. Okay, position. I just love this word. Retroperitoneal. Okay, towards the back. Okay, in the superior lumbar region. Or, alternatively said, on the posterior wall of the abdominal cavity. Think about that. The posterior wall of the abdominal cavity. Makes sense. Okay. The right kidney is lower than the left. The convex lateral surface, concave medial surface. The renal hilum, okay, that's that indentation, leads there to the renal sinus. Don't worry, I got better slides in this one, okay? The ureter, renal blood vessels, lymphatics, and nerves all enter and exit through the hilum. So the hilum is the only road in, and it's the only road out. Okay. The supportive tissue there for the kidney, there's a lot of fat in there. Okay. Adipose tissue. And really, there's fat everywhere circumventing our organs there because it's a good space filler. A good cushion holds things in place, right? So you've got, there's the renal fascia, okay? And this is the anchoring outer layer, dense fibrous connective tissue, holds the kidneys right in place, okay? Your fat capsule, okay, your adipose tissue, all right, holds everything in place as well. Fibrous capsule there prevents the spread of infection, okay? And I think you guys, hopefully there you guys have noticed there, the heart, the lungs, the kidneys, everything has its own little yard space, so to speak. You know, it's got its own little area, and it's got its own protection because, you know, the kidney, the kidneys are saying there to the liver, I love you, but we just gotta, separate ourselves, right? And there's all these capsules there, and everything is just protected, okay? What we've got here now, this is a more detailed diagram, and this is where we're going to be moving to. The one of the videos there, was it, which one was it? Oh, that was the gluconeogenesis. But there's a really good video I've embedded in here. There's, 2 or 3 of them here. And they're good. For this video here, it's more of the macro, which is this stuff here. Okay? Stuff there that we can see with the naked eye. And we'll zoom in here and we'll have a look. You'll see this, well, actually, we'll just start with the blood flow. Okay? Blood comes in here, there's your renal artery. And you remember that artery, massive pressure, and it just goes wham, right into the kidney with no place to go. And the reason because of that is because the kidneys need high blood pressure. Okay? Because that blood is coming in, and it comes in with such a force, wham! And glucose, all these ions, everything, all these different substances, they come off. All right? And that's what this filtrate is that will eventually become urine. Okay, so, and you'll see how this goes here. Blood comes in, and it immediately goes to the outside. Okay? We've got the cortex. And that's this one right here. That's that outside. All right? And it is very different from this section in here. But they work together. And we'll get into that. This is called your medulla. So that's the cortex, which is just the outside. It's very, very visible on a real kidney. No, you can't miss it. All right? Because I know cartoons can sometimes distort. Like we were talking there about the heart, right? And all my cartoon pictures of the heart. Oh, okay, that, then no problem. And then when you get to the heart, you go, oh my gosh, where did the ventricle go? So, but the kidney is a lot easier. There'll be a lot less stress when it goes to writing this paper. So there's your cortex, and there's your renal medulla. Sorry, I'm gonna say renal kidney. That's kind of the same thing. And you'll see there that the blood comes in and goes right to the outside. Okay? And where the outside is, this is, like the neuron is the smallest unit of the nervous system. Or an amino acid is the smallest unit of a protein, right? The smallest functioning unit there for going on in the kidney, okay, is these guys here. And these are called nephrons, okay? And I'll deal with these there later on. They're cool, and you'll see how, like, the blood goes right to the outside edge and then comes back in. It gets filtered, okay, from the cortex through the medulla. And in this section in here where the two sections meet, okay, that's where you get these nephrons. And these nephrons are the ones that are doing the filtering. Okay? And you'll see how there's this stuff up here, but then there's an obvious and clearly evident loop going down, a single loop, and then coming back up, and then more of this again. There's a reason for that. We'll get there. Okay? So the blood comes in, goes to the outside, hits the cortex, comes down through the medulla. Okay? And then down in this area here, I'm just going to zoom in as best as I possibly can. So the blood comes out here, and you'll see that, there we go, blood comes out. Right here, comes down here, gets filtered. Okay, and then now the urine, or the precursor to urine, it's not fully urine yet. It comes down here, all right, and comes down into this area. It's called a minor calyx. Spelling is here. Okay, there's a minor calyx. So at the bottom, you see these triangles here? We call these the renal pyramids. So this layer, this area here is called the medulla area. Okay, all of this. One of these guys here is kind of like, we call them the renal pyramids, okay? They're like these inverse triangles, okay, on their head, right? And what happens, the blood comes around, the filtrate gets filtered out, and it comes down here, hits a minor calyx, which then moves to a major calyx. See? Minor, 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 into a major. Okay? All right? And then it moves down into the pelvis, where it is then, where's my ureter? Right down here. Okay? So there's no blood. This is not about blood in here. This is about urine formation. Okay? Urine comes through here and then out the ureter. The blood that came in comes out. All right? And you'll see there, it comes around and then through, okay, there to your vein, which then goes to your vena cava. Okay? So there's, the blood gets filtered, but the blood comes out as blood. All right? And what is filtered off the blood, the urine, the pre-urine cursor here, okay, the precursor, comes down here, a minor calyx to a major calyx there to the pelvis, and then out the ureter and down to the bladder and out the urethra, okay? And quite honestly, that's what's going on here. That's all there is on the macro, all right? And we'll go into more detail. We'll break all these up in here. So again, you have the cortex. There's your medulla, which houses there your pyramids. Okay, the blood gets filtered. The filtrate comes down here. You'll see this one here doesn't show up, but there's little dots here, kind of like when you're straining spaghetti. You know, those little holes in the sieve there. There's these little holes here, okay, called renal papillae, which I'll show you there later. Okay, and they allow the urine to come out into the minor calyx, which then flows into a major calyx and then out. Okay, just another shot here. Okay, this is from a cadaver, so it's you know, it doesn't really look that appealing. All right, but you can definitely tell, like in a fresh one as well, it's even more evident. You'll see there that there are my my pyramids. Okay. There's your cortex. This is all your medulla area. Okay. In between the pyramids there, you have what's called renal columns. Okay. That's where your blood comes back through. Minor calyx to a major calyx, your renal pelvis, and then you see here that there's your ureter down here. Okay. Which is all evident right here. Okay. Hopefully there's if there's any issues, let me know. This video right here, it's from some community college. I think they're in the States. I've used it there the past couple years, and it's pretty good. If you want to pause the video and watch it there from 0 to about 4 minutes, 38, 39 seconds there, it's more of a macro view, like this kind of a view, and Buddy talks there about all these things there that I basically just talked about, so you really don't even need to watch the video. But you can, if you don't believe me. Okay, here's another one there. This one here is a good one. I'll just show a little clip. And you'll see here that this is a fresh one, and you can totally see there's your cortex, there's your medulla, there's your pyramids there. And why it looks all nice and blue and all this kind of yellow is because they've injected it there with some wax. Okay, so that you can see this or see that. We're not going to be injecting these things with any type of dye or any color, but that's basically what we're looking at. It's a good little video there. Have a look. All right. Ta-da. Now, we're going to move into a little bit of the blood. It plays, when you're talking about the kidney, yeah, the blood goes into the kidney and wham, massive pressure, and the kidney is just basically a wall. Stops this blood. The pressurized blood releases these things there that we don't want in the blood, and then your urine is made. But the blood is not finished yet with its job within the kidney. And we'll show you this, okay? So the renal artery there, they deliver about 1/4 of the cardiac output there to the kidneys per minute. Okay? So how much blood do we have in our body at any given point in time? About 5 liters. And every minute our blood gets pumped. 5 liters, your heart pumps 5 liters of blood. Basically, that's generally the rule. And every minute there, your kidneys, they get hit with about 1,200, 1,300 milliliters of blood. So about 1/4 of all your blood gets filtered every minute. Now, is like, how do I say this here? The blood doesn't get, so when 25% of the blood gets filtered this minute, another 25%, another 25%, another 25%. So what, every 4 minutes your blood is 100% filtered? No. It's random, right? So this 25% could go, and then that 25% could go next time. The first 25% could get it again. Could get refiltered. That's just how it goes. It's random there. The arterial flow, so what am I looking at here? So about 1/4 of the blood gets pumped there per minute. The arterial flow into and the venous flow out of the kidneys follow the similar path right through the hilum, okay? Nerve supply is via the sympathetic fibers there, okay? And so that's what's going on there. Another slide showing the same thing. There's your cortex and your pyramids, major minor calyx, okay, your renal artery, vein. Have a look. There you go. This slide here I'm talking about the blood flow in to the kidney. All right, because the blood comes into the kidney, but then its job is not done. It's still got another job to do. So it's not just in the kidney and out of the kidney. I'm filtered, I'm clean, I've had my shower. No. Blood comes in, gets filtered. It's got to loop around because things that were filtered, maybe they need to get back in. So you'll have a look here, and I tried playing with this there, just hopefully there you guys can follow, because I had trouble following this. So the blood comes in there through the renal artery. Wham! All right? And then you get the branches coming off the renal artery. We call those there the segmental arteries. Okay? And you'll see there, comes in, we got our segmental arteries, which eventually turn into our interlobar arteries. And you see where they are going? Okay? Right up the columns. Okay? Get that blood, you got to get it right out to the outside. Why? Because we get the blood there to the outside, and then we filter it, and the urine will come down here, and out we go. So, and then we have what's called your arcuate artery. So there's your renal, segmental, interlobar, and then these ones here that kind of are in the cortex, kind of on the cortex medulla cusp. We call those there your arcuate arteries. Okay? And those ones there, they get it up into the cortex area. Okay? And you'll see the little guys here. We call those cortical radiate arteries. Okay? And that's where, you know what I mean, we're at the smallest level right there, and that's where the blood is going to get filtered. Okay? So, and they're in this order, which I put right here. Okay, this is over here. Renal artery, segmental, interlobar, arcuate, cortical, okay? And we'll get to this there. And just to show you the way out, it's basically the opposite. Okay, you'll have your cortical radiate vein, your arcuate vein, interlobar vein, okay? And so there's no segmental vein, okay? And they're all right here, okay? And you can see there that there's your arcuate, your cortical radiate vein right in here, okay, to your arcuate, interlobar, renal, and out. All right. And just a recap of those guys right here. All right. This is a good one to know. All right. Good, good, good. Welcome to the nephron. Now, this is a highly, highly, highly simplified diagram of the nephron. This is the microscopic beast that filters the blood. All right. The going back into here, you know, your renal artery, your segmental, okay, interlobar, your arcuate goes along there, and then these little guys in here, okay. See if I can show you right here. These are your cortical radiate artery. All right. Now, after the cortical radiate artery, what happens is, okay, we have an afferent and an efferent. Now, an afferent artery, how I know it is through nerves, okay? And there's an afferent nerve and an efferent nerve. Afferent nerve is coming towards the self, at home. Afferent, at home, it's coming towards me. So an afferent nerve is traveling from my arm to my heart, okay? An afferent artery is traveling towards whatever it's going to, okay? An efferent with an E is an exit artery. It's leaving. So this one here is your afferent artery. This one here is your efferent artery. I will get you on one of those, okay? And you'll see here that the artery, and it is an artery, pressure, comes right in here to what we call there, this is called the renal corpuscle, okay? And basically, you have what's called the Bowman's capsule, which is just an extension of this tubular system, okay? So the Bowman, this is called the renal corpuscle, all right? And we have the Bowman's capsule, which is just an extension of this, all right? Now, what is this? I'll get there. Inside, you'll see there that this is your afferent artery, and then it just, you know, you've got all this glomerulus artery in here. And what happens is the blood comes in here with such force, okay, that because of this pressure, this filtrate, these things come off of the blood and they diffuse off the blood. And so the precursor to the urine, or the pre-urine, or the filtrate, the stuff that was filtered out, called filtrate, starts to move along here. Okay, so your Bowman's capsule is just an extension of this tubule system. All right, the glomerulus, this is on the inside. These are arteries. The blood is coming in here, and wham, and the filtrate all comes off. All right. I don't know if you've seen Avengers Endgame, where the Ancient One there hits the Hulk, and boom, and the Hulk's spirit comes out the back of him, right? And it's kind of like the same thing. Not really. I just thought that I'd throw some Marvel Universe in there. Yes, I like comic books. Okay, we'll get into more detail here, but just remember your afferent, okay, comes in here with massive pressure. The filtrate is filtered off into, okay, the Bowman's capsule from the glomerulus. The blood that was just filtered now moves along the efferent artery. But it is not done. We will see that blood again, I promise. Okay? The filtrate comes along and starts moving along what we call the proximal convoluted tubule. Okay? And things are removed. Like, this is not the final urine. All the filtrate that was filtered off right here is not the urine. Okay? Just to tell you that the kidneys filter, it's going to sound unbelievable. The kidneys on a daily basis, 24 hours a day, they filter 180 liters of filtrate out. So they pull 180 liters of filtrate out in a 24-hour period. Now you're thinking, okay, man, what's going on here? I only got 5 liters of blood. How is this thing pulling out 180 liters of filtrate a day? Well, it is. Trust me. And then as this 180 liters of filtrate travel along here, things get reabsorbed. Okay? To the point where in a given day, we will create over 180 liters of filtrate, but we'll only go pee maybe a liter, liter and a half. So 180 liters of filtrate is filtered, but we only urinate about a liter and a half. Okay, so it's basically less than 1%. All right, so here we have what's called the proximal convoluted tubule. Proximal convoluted tubule. Proximal means closest, convoluted means twisting, tubule means tube. So the closest twisting tube, that's what that actually means in normal English, right? So don't get confused by these silly scientific words, okay? Just closest twisted tube. And you'll see there that different things are filtered out, okay? And we'll talk about these things. But you realize here, this is the cortex. Remember that top part in here? Okay. This is where the cortex is. Cortex is in here. And then down in here, this loop of Henle. See, we've got this descending limb, and we've got the ascending limb. And we've got this hairpin turn down here, called the loop of Henle. All right? This dips down into the medulla, your medulla pyramids, your renal pyramids. Okay? It's pretty salty in here as compared to the cortex. And by sending this filtrate down here, okay, water is removed to the point where it gets pretty concentrated down here. And I'll talk more. I'm just introducing this at this point, okay? There's still lots more to go. So pause the video, take your time. This is going to take a while. But this is just as important as the heart, okay? And maybe even more. All right, so we've got our ascending loop. Things are still moving and shaking here. That initial filtrate is still traveling down here. Things are being removed. Things are being added. Generally, we have absorption, okay, where the filtrate, things are removed. And then things may be secreted back in. And then on our final leg here, we're almost at the urine stage. All the urine there is collected into a collecting duct, which then goes to the minor calyx and the major calyx and all that kind of stuff. All right. So maybe one of the questions is you're asking is, you know, like, okay, in this oversimplified nephron, like, I don't know, I just see white space behind here. Like Ian, you're telling me there that things are being removed out of this tubule, and things are getting removed and put in all back in here, eventually creating my final product of urine. Well, how? Where are things getting absorbed from? This is just a white background. Well, let's get into this again. This is just another shot of the nephron. Okay, there's your afferent arteriole. Okay. And it hits the glomerulus, all right? And you'll see there that this is your Bowman's capsule, all right? You see that? It's empty. It's just an extension of, here's your proximal convoluted tubule, all right? And you're thinking, okay, it looks a lot different than this. It's okay. Everything is here. There's your glomerulus. The afferent blood comes in, gets whacked with pressure. The filtrate filters out, okay? And the blood now leaves the glomerulus, and now it is in the efferent artery, okay? And you'll see there that it comes around. And you'll see there that these the efferent arteriole, okay, comes around, and it basically circumvents the nephron. And you'll see there peritubular capillaries. Capillaries, their only job is to do what? Move things from A to B or B to A, right? That's the only place where exchange happens, is in the capillaries. And you'll see there that the nephron is completely covered in capillaries. All right? And here's your proximal convoluted tubule right here. And then there's your descending loop. Okay? There's your loop of Henle. Here's your ascending loop. And then here is your distal convoluted tubule. Okay, you got the proximal, and over on the other side of the loop you have the distal convoluted tubule, which is this one right here. Okay, so you get the proximal and the distal. They're just separated there by the loop. Okay, so and then the filtrate eventually makes it there, okay, to the collecting tubes, where then it's gone down to the calyx and the ureter and out. But you'll see the point of these capillaries here is for absorption and secretion. So the blood comes in here, wham, the filtrate is filtered. But it's kind of an indiscriminate filtration process where anything that'll go through, like RBCs are too big. They do not end up in the filtrate. RBCs continue on here. Big honkin' plasma proteins. There's lots of big proteins there in the blood. They do not get filtered. Okay? What does get filtered? Right off the bat right here, you got water, glucose, amino acids, small, right? It's basically everything there that's kind of small. You've got sodium, carbonate ions, all these different ions, potassium ions. They're small. They'll go right through. You have creatinine. Okay, that'll also come out as well. And also urea. Okay, and so these all come out. But by no means is this finished urine product. Okay, because all of this stuff is filtered out. 180 liters every single day is filtered out, and 178.5 liters is all reabsorbed. I'll say that again. 180 liters of filtrate is created daily. 178 liters is reabsorbed here by these paratubular capillaries. Okay? Very, very, very important. So the kidneys, you look at that, they're filtering 180 liters of filtrate a day. They need that blood pressure up. And if they ain't getting it, they will get it. Okay? Good. Well, let's keep moving. This is the macro view there for the kidney. Have a look at it. Okay? The macro view was up here. This is the second part of this one. There's the macro, okay, from 0 to 438. And this one here is the micro. It follows right what we've been doing here. It's all about the nephron. It's all about the glomerulus, the Bowman's capsule, the proximal convoluted tubule, loop of Henle, descending, ascending, and your distal convoluted tubule there, okay? And it's really good, okay? So please have a look at that. I don't anticipate any issues there with that. It's a good one there. And where we're going to go there today, I'm not even looking at the time. Oh, yeah, we've got about 7 minutes left and until we'll take a little break. But we're just going to go into the nephron itself, okay? The glomerular capillaries there. And where are we talking there? That's in here. You'll see the glomerular capillaries. Do I have another shot here? These ones in here. All right. So the glomerular capillaries are specialized for filtration, and they remove the waste there from the blood and regulate water electrolyte concentration. Easy peasy. These are the only capillaries in the body that are fed and drained by arterioles. Okay. Arterioles there. Well, there's arteries, and then there's arterioles, right? But still pressure. There's still smooth muscle in these arterial walls, and they can create the pressure. Capillaries, they don't have any smooth muscle, so they can't augment the pressure. Okay, capillaries are too small. This allows the blood pressure there in the capillary bed to be very high and forces fluid and solute out of the blood into the Bowman's capsule. So high blood pressure forces the fluid and solutes out of the blood. Okay, what we were talking about there, the water, the potassium, sodium, amino acids, creatinine, urea, they're all small molecules, so they'll just go right out. Okay. Most of the filtrate is reabsorbed. I think we just said 178 liters of it is reabsorbed there by the peritubular capillaries. Okay. We're going to be using this shot. I think I've got a whole bunch of them. I've used the same shot again and again and again and again, but I just wanted to go through it here. Okay. Your renal corpuscle. Okay, there's your afferent, efferent, and remember the efferent comes around and swings all in here. All right, for the point of reabsorption. All right, so there's your glomerulus, your capsule, your Bowman's capsule. Okay, pressure blood comes in, and there's your proximal convoluted tubule. Okay, there's your descending, your ascending. There's your loop of Henle, distal convoluted tubule there with your collecting duct. Just a shot of a glomerulus, just to show you that I'm not lying. Which one is this one here? Yes, Nashville hot chicken sandwich, wonderful. Thank you, thank you. I could have lived my whole life without that. Holy, another commercial. Boy, if YouTube's really kicking them up, eh? Get out of here. Yes, this is a nice one. And this one here, give this one some detail because it talks about, I love her voice. It's great. She has so much enthusiasm. And what she's talking about there is what is happening in the proximal convoluted tubule. What is being absorbed, reabsorbed, it's all about reabsorption. Okay, here, what's going on here because it's different than what's going on here. So there's the proximal convoluted tubule, you'll need to know what's going on there. The descending loop of Henle, you'll need to know what's going on there. What's happening right here? It's very concentrated. Okay, I'll go through this step by step. The ascending loop of Henle here, there is different things going on here, and then we have the distal convoluted tubule. Things are different here as well. So there's 1, 2, 3, 4, 5 parts, okay, of things moving in, things moving out. What's moving in? Let's find out. So your renal corpuscle, there's your glomerulus and your Bowman's capsule. Okay, they're calling it the glomerulus capsule. That's fine. Okay. You'll see here that there are these fenestrated endothelium. Okay, and these are the ones there that allow the filtrate to pass from plasma, okay, into the capsule, and that there are these let's call them porous, because that's basically what they are. Okay, there are these porous endothelial cells there that allow filtrate to pass through. And that's the mechanism. That's the sieve. That's the spaghetti strainer that is filtering things out. The glomerular capsule, the Bowman's capsule here, simple squamous epithelial cells. You could zoom in. I'll zoom in for you because I can. And you'll see there. These are these simple squamous epithelial cells. There's another shot of your fenestrated endothelial cells there. Okay. There's the parietal layer, which is the simple squamous. Okay. There's also a visceral layer, branching epithelial podocytes. Now, where are they? Oh, I think they're the next one. They basically extension terminates there, and process there. What's going on here? Into the back. There we go. The what we're talking about here is basically just filtration. And the filtrate comes in, or the blood comes in, and because of this pressure, all the filtrate there comes on out. So have a look at that. What do we got going here? So now we've got the filtrate is now moved on, okay? And it's now in the Bowman's capsule, and it's now moving into the proximal convoluted tubule. Okay. These are cuboidal cells there with dense microvilli, large mitochondria, function in reabsorption and secretion, and we'll get into more detail of what is reabsorbed and what is secreted there. But what we've got here, mainly reabsorption that goes on here, okay? Sodium, 65% reabsorbed here. Chlorine, wherever sodium goes, chlorine goes. And generally, wherever sodium goes, water goes. Did I just say that? Wherever sodium goes, water goes. Okay? So the chlorine is picked up. 65% of the sodium, 65% of the chlorine, 65% of the water through osmosis. Okay? Potassium, about 65%. Bicarbonate. Okay, very, very important bicarbonate. We utilize that there to maintain our blood pH. All right, about 90% of the bicarbonate is picked up. This one here, I do want you to know, 100% of the glucose and amino acids are reabsorbed here. So you'll see there that the glucose and amino acids, they're pretty small molecules per se. They get thrown out of the blood into the Bowman's capsule because they're small, okay? And then they come back through the proximal convoluted tubule here. And glucose and amino acids, man, we don't throw that stuff out. So immediately that stuff is reabsorbed, okay? Which then, you know, and you have to think, when you go to the doctor and you're sick, doctor tells you to urinate in a cup and bring it in for an analysis. You bring in your urine there in a cup, and it, you know, if one of the first things is if we see glucose in your urine, we see amino acids in your urine, you got troubles, because that is not supposed to happen, which is one of the reasons why it's a pretty basic test. Okay. What are we on to now? I gotta zoom out here. Are we almost at, I think we are. Ladies and gentlemen, please let's take a 10-minute break. I'm going to pause the video. All right, I'm going to stop the video. I'll create a new video. I will keep the WebEx link open though. Okay, so I'm not going anywhere here. I'm just going to turn the video off. I'm going to turn the sound off so you guys can go get a drink of water and do whatever you need to do. So let me just pause this here.